The sun has been shining for 5 billion years. That is 500,000 times longer than a coal-powered sun could possibly last. You see the problem, and it gets stranger. Chemical combustion burning is fundamentally a process of rearranging electrons around atomic nuclei. The nuclei themselves remain untouched. Whatever is happening in the sun is happening at a deeper level, a more fundamental level, a level that our ancestors had no words for, because the process they would need to describe does not occur anywhere on the surface of this planet. Not naturally, anyway. To find the real answer, we have to go somewhere most humans have never conceptually traveled, inside the atom itself. Imagine holding a hydrogen atom in your hand. You cannot, of course, it is far too small. The period at the end of this sentence contains approximately 1 million hydrogen atoms lined up side by side. But imagine it anyway. A single proton at the center, the nucleus surrounded by a single electron in a vast probabilistic cloud. Now imagine 2 of these atoms side by side. Under ordinary conditions, they repel each other. Both nuclei carry positive charge, and like charges push away. This is called the Coulomb barrier, the electromagnetic wall that keeps atomic nuclei apart. On Earth at normal temperatures, this barrier is essentially impenetrable. Hydrogen atoms might collide 1 billion times a second and never, not once, fuse together. But the sun is not ordinary conditions. At the core of the sun, roughly 150 billion meters below the surface, you see the temperature reaches 15 million degrees Celsius. The pressure is 250 billion times the atmospheric pressure at Earth's surface. Under these conditions, hydrogen nuclei are moving so fast, packed so tightly, that something remarkable becomes possible. Not inevitable, just possible. Have you ever noticed how a tunnel through a mountain seems impossible until engineers find a way through? In quantum mechanics, particles have a similar trick. A hydrogen nucleus doesn't need to overcome the Coulomb barrier. It can tunnel through it. This is called quantum tunneling, and it is one of the strangest verified facts in all of physics. Particles can pass through walls they classically cannot cross. In the sun's core, quantum tunneling happens constantly. When 2 hydrogen nuclei come close enough that the strong nuclear force, which acts only at extremely short range, can reach across the gap, they fuse, they merge. They become a new nucleus. And here's where the magic happens. 4 hydrogen nuclei, through a chain of reactions, fuse to form 1 nucleus of helium. But here is the extraordinary thing. 1 helium nucleus is slightly lighter than 4 hydrogen nuclei. Not by much. About 0.7% of the total mass simply disappears. Think about that. Mass vanishes. It doesn't go nowhere. It becomes energy. Pure energy, described by the most famous equation in human history, E equals mc squared. That missing mass is multiplied by the speed of light, 300 million meters per second squared. The result is an almost incomprehensible release of energy from a vanishingly small amount of matter. Think about the last time you held a sugar cube in your hand. That small white cube of sucrose, perhaps 4 grams of matter. If you could convert even 1% of its mass directly into energy via nuclear fusion, you would release energy equivalent to several atomic bombs. The sun converts approximately 600 million tons of hydrogen into helium every single second. Every second. 4 million tons of that mass is converted directly into pure energy, light, heat, neutrinos, the warmth on your face on a spring afternoon. This process is called nuclear fusion, and it is not burning. It is something far older than burning, far more fundamental, far more strange. Burning rearranges electrons. Fusion transforms the nucleus itself. Burning is chemistry. Fusion is alchemy, the true alchemy that ancient scholars dreamed of but could never have imagined working this way. The sun is not a fire. it is a star. And those are two very different things. Now, pause. Let this breathe. Every photon of light that strikes your skin today began its journey in the sun's core approximately 100,000 years ago. That is not a metaphor. It is physics. The radiation produced by fusion in the core takes that long to random walk its way through the dense solar plasma, bouncing, absorbing, re-emitting before it finally reaches the surface and escapes into space. Then it travels 8 minutes across the vacuum to reach you. The warmth you feel right now is ancient. It was created before Homo sapiens drew the first cave paintings, before our species developed language, before we named anything. And yet here it is, landing on your face, entering your eyes, warming your coffee cup on the windowsill.